This is again I'm your eternal voice. Now we go to the last topic of colligative properties, which is known as the osmotic pressure. So, another kind of pressure, right? As I discussed yesterday, there's a lot of types of pressures, but now it's another osmotic pressure. Take note, just refer to the vanhoff factor if we say osmotic pressure, and normally it is more on the dissociation of solutes. Okay, dissociation of solutes, or it could be dilute solutions or ideal solutions, something like that. Okay, so it's gonna be osmotic pressure is equals to pi. Pi is pressure, osmotic pressure with uh, molar concentration, molarity times universal gas constant times a capital T gives a Bantle factor I. Okay? So as we can remember a while ago, I think last month, I'm discussing regarding the how to obtain pressure in terms of ideal gases, right? The only difference here, guys, and that's ideal gas, here is ideal solution. Okay? And if we talk about ideal gas, the compressibility factor Z is equal to 1, but for ideal solution, the activity coefficient is equal to 1. So A activity coefficient is equals to 1 for ideal solutions. Okay? This is theory, guys, okay? And then compressibility factor Z is equals to 1 if ideal gas. Okay? So, activity coefficient is more on the dissociation of solute into the solution. Okay, but compressibility factor, we have specific formula which is equal to Z pressure times the molar volume over the universal gas constant times the capital T. So in this situation, you can really prove that the gas you are solving is an ideal or not, so that you can use the PV in our equation. Okay? That's why sometimes we'll never do that because it's very clear in the problem that it's really behaving as an ideal gas by stating the STP, standard temperature and pressure, or by mentioning the word ideal. You don't have to compute for Z because that was obvious. Okay? But if it is not obvious, there's no word ideal in the particular problem, that the word IDEAL. And then there's a lot of gases involved there. Could it be air, ammonia, no, nitrogen, okay? Like that, oxygen, carbon dioxide, carbon monoxide. Okay, it's pretty obvious that this is an ideal gas. But it's not mentioned the ideal word, and there's no STP also, standard 2 by 2 2. Then you have to compute for the Z. Okay, compressibility factor. Since, for example, that is your topic at that math, then you don't have to worry because it is still ideal gas. Okay, but what if it is no longer the topic in that particular month? How can you say that it is an ideal? You get the point? Because normally as a student, we are focusing on the topic per topic on that particular, let's say, maths, semester, right? So it's stuck in our brain. And then if it is not already the topic, okay, and then there's no mention the K terms. K term is it's the word for that, okay? So problem for us. So the best thing to compute if it is an ideal gas or not is to use the compressibility factor Z is equals to pressure is the molar volume times the universal over the universal gas constant over the T. Okay. Now going back to osmotic pressure. Okay, the osmotic pressure can be related to the ideal solution activity coefficient 1. And then if you try to compute for the pressure in the PV and RT, okay, I already derived that, but it's easy to memorize. It already pressure is equals to CRT. Okay, because it will take time if you derive a lot, right? Okay, so this C and N is just equal are all concentrations. Okay, only the letter C stands for the concentration. The first letter is C, stands for concentration. And N is the molarity. The first letter is M, in which molarity is the expression of the concentration. So therefore, they are equal. The only difference, guys, is that in ideal solution, in osmotic pressure, we have to add the vanhoff factor I. But in the pressure relating to the ideal gas, we no need to compute with the vanhoff factor I because that is not related to dissociation. Okay? You get the point? Only like this. Pressure is equals to CRT. C is the concentration. Ganun lang siya. Okay? But if you love really to compute the PV in RT, something like that, okay, you can compute, but sometimes it will not be used because this is more simplified. Okay, this one. Especially if it deals with concentration. Because this ideal gas doesn't talk on the concentration. This is pressure, volume, for example, of moles times universal gas constant times T. It doesn't relate to the concentration. That way we derive an equation that relates to the concentration. That way we will automatically derive the equation in terms of pressure that contains concentration. And we don't have to stop up with this PV is equals to nRT. Okay? Not all the time. Though it is a popular equation, but it's not all the time to be used. Okay? Muna siya mga palangka. So going back to the osmotic pressure. Okay? So we have now a problem here. I just picked up this problem in, what's this? Oh my gosh. 1985 May board examination, chemical engineering board examination. This was how many years? 1985 chemical engineering board examination. Okay. So how can we compute this? Okay. Okay, this is a database from the PRC, Philippine Radiation Commission. Oh my gosh. This is gonna be like this. Okay, again, we need to solve this on the spot and then look for the answer. If the answer is the same we have here, then we are solving the correct way. Something like this, okay? Get mga palangga? Okay. I like to choose, this is really tricky naman, board exam kasi, diba? Okay, 25 grams of non-dissociating solute. Okay, 25 grams of non-dissociating solute. Okay. Okay. Like this, mga palangga, wait, dissolves in 500 ml of water. Okay. In 500 ml of water. Okay. Water, mga palangga. And then, no, ml of solution. Okay, sorry. Solution. And then, at 25 degrees Celsius. Okay. Meaning at ambient temperature or room temperature or standard temperature. Okay. The osmotic pressure. The key term here, guys, is osmotic, huh? Osmotic. If there's no word osmotic, then don't use this kind of formula. Okay? Stick to the pressure is equal to CRT or use the other formulas of pressure. There's a lot, right? Okay. So we have, I have to explain, there's a lot in the Bernoulli theory and also in the physics. Okay. The osmotic pressure of solution of the solution of solution, guys, is 15.28 atmosphere. What is the molar mass of the solute? Okay. I have to discuss what is the molar mass of the solute. Okay. So that's why this is a board examination 1985 because I tell you why. Of the solute. Gusto dyan lang ibubo ng estudyante so that di na makuha ang answer. Okay, first, I need to discuss the confusing part of this problem. First, they introduce a non-dissociating solute. This is the first issue. And since they know that an equilibrium property gas, we are dealing of dissociating of solutes, then why the problem is given a non-dissociating? So in the first place, it doesn't fit actually. That's the first issue. Okay, second issue. Okay, what is the molar mass of the solute? Okay, in this particular topic, we don't normally ask for the molar mass of the solute because this is not in the equation quantity of the osmotic pressure. Then, if you love keep on solving the same sample problems every time, the way that your instructors give you in your classroom, then you don't modify, then problem, you will find difficulty in actual examination like this. You will be shocked. Get the point? So this is the reason why we need to connect the previous lessons that we learned and then link to the present topic. Okay? Or practice so many problems so that you can encounter another way of solving it or another way of presentation of the problem which you did not encountered even before. Okay? So that, in the actual examination in the future, you will not be shocked. It's asking for the molar mass or the molecular weight that is not being discussed in your classroom instruction because your instructors are normally giving you the same sample problems pattern in the book for 5 years of teaching in that way, 10 years of teaching in that way, 8 years of teaching in that way, and they don't modify. And for sure, they will modify only in the prelim exam, midterm exam, and the final exam. Okay, because if they will not modify a bit, the examiners also will pass all. Okay, so sige lang ka-perfect ang mga students. So of course, there are also instructors who love to see students who are struggling. And there are also instructors that love to see students who are passing on. And there are terrors, and there are also passionate instructors like that, and there's also kind instructors. So it's up to the attitude and the character or personality of the instructors. But most of the times they are really terrors. Terrors, we need to say, trying to give difficult questions or problems in the exam, but during classroom instruction, they will never do that. Very easy only are their sample problems. So these are terrors. Okay? Because if you really love your students, if you want them to learn a lot, at the time of your sample problems, of course, you will also introduce difficult problems to them. At least 3 out of 5 or 2 out of 5 like this. Not all very easy to solve. So that this lang munganga, ini ka prelim, ini ka midterm, ini ka final. Munganga sila, especially to those students who are average. Okay, average meaning in the middle learning only, not the higher IQ students. Okay, students that doesn't love to think that much. Okay, because students that have a critical thinking, they love to think that much during their analysis of the problems. But this average or below average, they will never think that much critically. They will just depend on the instructor's sample problems and the way it is being solved in that way over and over again. Okay, so these are the two issues. Okay, like that. Because we don't normally ask for the molar mass of the solute in this kind of problem. Okay, but then in the board examination, it came out to be like this. Okay, so what if so many like this out of 100 items, 20 so many like this in that pattern in your classroom instructions? So okay, so it's better really to research a lot, okay, and go out from the backs of the classroom instruction, okay. So intensify more by having different sources, book sources, or everything you want to explore and maximize your intelligence potential. Oh, intelligence potential. Okay, nakakalakas na. Our solution here is ganon. Osmotic pressure is equals to, okay, C R T I. We will just use C, guys, ha? Because C is concentration. Okay. Anyway, you can use also molarity. Okay, but I'd rather use C. Okay. So osmotic pressure is given in the problem. The osmotic pressure of the solution is 15.28 half. So 15.28. So meaning to say, guys, this osmotic pressure is the osmotic pressure of the solution. It's not the osmotic pressure of the solvent. It's not also the osmotic pressure of the solute. You have to take note of that. Okay? Solution. Okay? And then concentration is nothing. Okay? Nothing. Okay? R, universal gas constant, as I told you over and over again, memorize at least two values which are common. And then if you don't know really the other unit, then derive that from PV and RT. Use STP, standard and temperature and pressure in your assumption, and you can get your own universal gas constant, even though you did not memorize. Okay? And then STP is temperature is 0 degrees Celsius and pressure is 1 atmosphere. You need to say at 298 Kelvin. Okay? Not the 25 degrees Celsius. Okay? So we're gonna take a universal gas constant that involves atmosphere. So what is that? 0.08206 liter atmosphere. Okay, moles. Kelvin. Then temperature is in terms of Kelvin. You have temperature in terms of Kelvin here? No, it's not. It is 25 degrees Celsius. Convert to Kelvin plus 273. This is gonna be 298 Kelvin. Okay, mga palangga? Then vanhoff I. Okay. Now, this is the second issue. Non-dissociating. So actually we don't put I because non-dissociating. So actually that is 0. Right? When the solute will never dissociate into aqueous solution or into water when you mix that. And then what's the purpose of the I? You get the point? There's no reason that you need to put that I vanhoff factor. But the problem in the examination insists still for the purpose if the students really know what they are doing. That's only their purpose. Because this is already in practical. You know, in practical, meaning to say not in reality. Because normally if you give the solute on the solution and it will never dissociate, what for? It will never dissolve. Even though how a trillion of times you will stir that in your glass, it will never dissolve because non-dissociating. You get the point? So meaning to say not miscible to water, insoluble to water or to any other solvent. So what for? Diba? So salbahis kayo ang problem, right? Okay. So you will interpret the I as 0 normally in common sense. If you don't have an idea about theory, you will say, by common sense, the I will be 0 because the solute will never dissociate. Ganon. So that is your first assumption. First assumption. Okay? Like that. Your I will be 0 because you said you have a non-dissociating solute will never dissolve or dissociate into the solution. Okay. Sa Bisaya pa, dissociation, dili mo bungkag o dili mo buwag ang molecules kung imong siyang ibutang sa solution. That's a dissociate. Okay? Like that. So you will interpret that as 0 at first. Okay. Now you have the concentration. What's the formula of molarity? Molarity is equal to the moles of solute over the liters of solution. Okay? Moles of solute meaning moles of non-dissociating solute because you describe the solute. Adjective. Okay. What kind of solute you have? What type of solute you have is non-dissociating. Okay. Describing that kind of solute is an adjective or description referring to the type and the kind of your solute. Okay? Like that. So this is most of non-dissociating solute. Okay? Okay, it will be your numerator. Okay. Now you have the liters of solution. I have 500 ml. So convert that automatically to liters. because that is liter solution in molarity. Okay, it's gonna be capital M, most of. Let's just make it an abbreviation for non-dissociating solute because it's very long. So it's gonna be NS, NDS, non-dissociating solute. Okay, moles of NDS, meaning non-dissociating solute, over the liter of 0.5 liters. Now, substitute this concentration molarity in your original equation of osmotic pressure. Okay? 15.28 mga palangga is equal to the moles of non-dissociating solute over 0.5 liters. Ganon. Okay. Times the universal gas constant. Guys, anytime I speak about universal gas constant, but you can also say that gas constant only, for generic or typical way of expressing that one. You don't have to say universal all the time, universal all the time. But for me only, for preciseness of the discussion and for technical information, that it's really a universal gas constant that it is referring here. But actually, it's also correct if you say gas constant. But to be more precise, you put universal gas constant, the word universal. Okay? Si may buong kasi kung universal. Ano ka? Diba? So, okay, 0.082. To be precise lang talaga siya, guys, ha? Okay, liter, atmosphere, mole, Kelvin, and 298 Kelvin mga palangga. So cancel the moles, cancel the Kelvin, cancel the liters. So many will be cancelled and cancel the atmosphere here. Okay, and what will be left here is the I. Why did I solve for the I mga palangga? I solve for the I because I have doubt whether the value of the I is whatever or either zero. Because if I put that zero, all your quantity will be zero. You cannot solve already. Anything will be multiplied by zero, it's always zero. So how can we solve now? If we treat vanhoff factor is equal to zero, if we feel just based in our common sense. What's our common sense is? Our common sense is non-dissociating solute. It will never dissociate. Okay? Providing we don't know the theory yet and concept. If it will never dissociate, by common sense, I is zero. Right? There's no value. If there is a value, then it will dissociate. Okay, that's our first assumption. Then our second assumption, we need to compute for the I because we are not sure. Okay? We are not sure, so we need to determine the vanhoff factor really, if it is really whatever, or for this non-dissociating solute. Okay, compute for the I. Ganon. Basic math. Calculator please. Nakakalimutan ka, diba? Okay. So it's gonna be like this. So 298 mga palangga times 0.08206 times, nakakaloka. Wait, yes. Okay. It's gonna be like, okay, 0.08. Guys, remember the rule of algebra? PEMDAS and, what's that? PEMDAS. Meaning to say, parenthesis, next is exponent, next is multiplication, next is division, next is addition, last is subtraction. That operations, you will follow the sequence to compute. If you will never follow that, your answer will be wrong. That's basic in algebra. Okay, PEMDAS, or let's say MDAS. Sometimes the parentheses are not also included. Okay, but here there's a parenthesis here a lot. So we start with the parentheses. Do that first. Second, if there's an exponent. Third, if we multiply. Fourth, if we add, division, subtract. Follow the sequence because if you will never follow that sequence, you will be wrong. Okay, just like here. Okay, so we have here the parentheses. So compute first the parentheses before you multiply in this fraction. Because that's PEMDAS. You go first for the parentheses. Okay, because if you try to compute this first and multiply that there, you will become wrong. You get the point? Or if you crisscross this immediately, this denominator here is not the denominator of all the quantities that we multiplied here. So do not do that. Okay, do first the parentheses prior to multiply that in this ratio, and then do the cross multiplication. Okay, or simplify further. Okay, something like that. Okay, be careful. Really, this is really tricky in math. So many will fail on this. Really, for the PEMDAS rule in algebra. I'll tell you. Okay, so I is equals to 0.0806 times 298. Okay, so then divide because PEMDAS. Okay, then divided by 15.28. So our I, guys, is, what's this? 3.20. Okay, again, it looks like very big. Okay, 0.08206. And I don't want to consider a very big I. Charot. Okay? Nakakaloka. Okay, 1 divided by 0.5 times 0.08206 times 298 is equals to, okay, 48.28 of 15.28 divided by 48, 15.28 mga palangga, okay, divided by 49.8. Oh, so it's gonna be point something lang yun siya. Okay? Okay, so point siya, guys. So let's have now a new assumption of our I. Okay? Ganon. Okay, because we don't know yet, mga palangga. Okay? Is equals to, ganon siya, chuba-chucho. Okay. And then it's gonna be 24.45, ganon, chuba-chucho. And then ganon, 0.5, ganon. O, diba? So it's gonna be, okay, ganon. So it's gonna be 0.5 times 15.28 is equals to, ganon. So it's gonna be divided by 24.45 is equals to 0.312 is our I. See, 0.312. Okay, it's less than 1. Meaning to say, if we have a non-dissociating solute, our vanhoff factor will be less than 2 to 1. Is this really correct? So because we don't know yet. Okay? Like this. So we have now two assumptions. Our I will be 0 and our I will be less than 1. Right? So this is our assumption. To come up with a theory. Okay? What is really the theory all about? Meaning, we are not solving here just to get the exact answer. We are solving here to prove the theory. It's gonna be the reverse. Because most of the times we solve problems because we need to prove if it is really correct by the numbers itself. But here, we are solving to prove the theory if it is correct. Okay? Reverse. Right? So I is equals to less than 0. Assumptions to assumptions now. Our I will be less than 0 and our I is equal to 0. But I is equal to 0, sure, it is not because it will become 0 all if you try to compute. Okay. Now, use I is equal to 0.312. So we mean of that factor, assuming that it will dissociate, because it will still dissociate mga palangga because there's still point something. Okay? So the unit for that is mole. Okay, mole of ion. Okay, mole of ion. Okay, because why? Because of the definition of the colligative property. Okay, colligative property is dependent on the concentration of the molecules of ions of the solute and the particle, something like that. Okay, but not to the identity and the nature of the solute. Means whatever the type of solute really is, we are not concerned for that. We are concerned only for the concentration of the solute molecules, particles, and ions. Okay, like that. So matabo. So namatay 0.312 mole ion. Okay, now molar mass is the required. So molar mass again because I taught you so many times for this. Molar mass of molecular weight is equal to the mass over the number of moles. Do we have the mass here? Yes, we have 25 grams of non-dissociating solute. So put that here, 25 grams. Now our number of moles. Use this mole ion. So 25 grams will be 0.312 mole ion. So we have now the gramole. which is the unit of the molecular weight or the molar mass in which it is asked by the problem. What is the molar mass? As I told you over and over again, molar mass is just equal to the molecular weight. Okay? Molar mass is just equal to the molecular weight, and molar mass is just equal to the molecular mass also. Okay? Like that. So, pila ang atong kuan? Molecular weight. 25 divided by 0.312 is equals to 80.12 grams per mole. 80.12 grams per mole. This is our answer. 80. Okay. Now, if the backup question in the examination in the future will say, what is the compound all about? You will name, and you have now the molar mass. Go to the periodic table or compound of elements, and then match that there. What is this organic compound or organic compound? Then name it, and then bingo, you can get the correct name. Because it's not defined here, it's not mentioned. What is this non-dissociating solute all about? Meaning unknown. Okay, unknown sample. The unknown sample is being added with water to machucho at certain temperatures. This is basically qualitative chemistry. Okay, meaning you need to identify what is the amount or what is really the chemical, the compound like this. It's not the amount, sorry, because that is quantitative. Sorry, it's the qualitative. What's the name of the element, of the compound, the acid, and the base in your unknown sample in your solution problem here, or qualitative property solution problem here. Okay, so in that way, I have the molecular weight, then I can determine what is that. Okay, but since this problem doesn't ask you, okay, but in the future, it may ask you as a backup question. Letter B, what is the element and compound? Is this, ganon, so A, blah, 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 so and so on. You have to choose the correct answer. Okay, now we have 80.12. Okay, ganun mga palangga. Now, we are not still yet through in the assumption of the I. Okay? For the non-dissociating. Because this is, what we call this is unusual. Okay, unusual meaning it deviates to the theory. Because the theory of qualitative property, as I told you, is always dissociating solute, not a non-dissociating solute. Okay? And then the problem give the non-dissociating solute. So it will become a headache, right? Okay? Now, we need to solve in another version. Okay? For this, we will try. Okay? We'll see later if it is correct or not, huh? Because I obtained the answer already. Because, you know, if you solve directly and then it's not a challenge already, right? So, I don't want to be like that. Okay. So, we want really, biglaan. Okay. So we need to solve another version because I found it not really logical, meaning not really reasonable enough. Though we obtained the answer and have also our assumptions, but it looks like I'm not contented. So we go to the another option. Okay, so we have the pi, 15.28. Atong i-manipulate, okay, the problem, the formula. So 15.28. Okay, let's say, let's say our I is 1. Okay, 1. Okay, third assumption will be I is less than, greater than 1, but equal to 1. I is greater and equal to 1. Something like that. Meaning to say, it will never less than 1, but it will go higher than 1. That's our third assumption. Okay. Vanhoff factor is greater than 1 and equal to 1. Okay. Just like this and like this in math. This one. Okay. Our first assumption, I is equal to 0. In case, maybe it's not possible. Okay. I is less than, no, yes, less than 0 because we obtained I which is 0.31 to a while ago. So that is less than 0. Now we will reverse. Let's have an assumption. But our I is less than 0, we get that through solution, giving the solution. But this one, we are having our assumption first and then solve. Okay? Like that. So our assumption first is our Vanhoff factor is minimum at 1. Minimum at 1 meaning to say equal to 1 but has the possibility to be greater than 1. Okay. So our C concentration, universal gas count at 0.08206 times 298. We will solve for the concentration here. Concentration or molarity. I don't have to show the units to be cancelled because it's a waste of time. It's just the same. Do that by yourself also. Cancel, 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 bachu, bachu, bachu. Okay. Now, what is the concentration value? Mga palangga. Okay. So, ganon. 0.08206 times 298 is equals to 24.45. Ganon, bachu, bachu, bachu. Then 15.20. What is our value of our concentration? Wait. So, 15.28 divided by 24.5 for 388. Oh, it's gonna be our concentration is 0.622. Concentration is 0.622, mga palangga. Okay, moles per liter. But it is not yet the molar mass. Convert this to molar mass. How can we do that? Okay, so we have 0.622 moles per liter. Okay, let's do conversion. Okay, you get the point. So if we have a concentration of 0.622 moles per liter and we have the volume 500, so we do this like this. So 0.622, dimensional analysis, the way of solving. Moles per liter and then multiply by 0.5 liter to cancel the letter, and then we have now the moles, right? Like this. How much is our moles? Okay. Ganun, diba? Check comprehension mga palangga. Okay? Check comprehension mga palangga. Okay? Times 0.500 is equals to 0.3112 our mole. Okay? So if you have the mole and then compute for the molecular mass, molecular weight. So we have the mass given 25 grams divided by 0.312 moles. Molar mass is 25 divided by 0.312. So we obtain the same molecular weight or molecular mass by having different assumption. Wow! Amazing! Diba? 80.12 grams per mole. Ganon. And we need to take a look for our answer here. Pagbaan sa taan. Okay. Okay, question number 92. Yes. Perfect. 80 point something, but the point is not the same, but it's just okay. 80.12, but the answer there is 80.15666 like this. But we have 80.12, so more or less we have correct answer. Now we choose which among this option is correct. We use different assumption of our I, but then we obtain the correct answer of the molecular mass. Okay, and now that's the time we need to research. Research the book, your references, theories, www, social media, encyclopedia like this, chemical engineer's handbook, physics book, chemistry book, Google search, like that. Then we need to research. Okay, so the best thing is to research by Google search. Now, okay, what is really the value of I if non-dissociating? Okay, so that we can come up the best version is that the way what is our value of I for this. Okay? Though we get the same answer. Mga panang. Okay? Diba? Ang sa akin ano mga problems guys, mo nagibutang dyan sa board exam. Okay? Nakakalawa ka. Okay, it's here if the solute will never dissociate, the value of vanhoff factor is 1. Hala! So, ano pala guys, if the problem will have, okay, it's first time guys, really. I already now, I'm already a chemical engineer and I already graduated na being chemical engineering. But now I know that the non-dissociating solute is the I value factor is just equal to 1. Imagine how many years just I know. 20 years plus when I was graduating in my school. So things like this, right? We need to say, we did not discover yet even though we studied a lot. Okay? So it took me 5 years to finish the course, right? But just now I know that the non-dissociating vanhoff factor value is equal to 1. Okay? So memorize na, including me. So we will now put in our brain cells that the vanhoff factor of all non-dissociating solutes all over the world is equal to 1. So that if we can encounter a problem like this, then bingo, makuha na yun siya. If there's a word non-dissociating solute. So ano na, non-dissociating solute is equals to 1. Or I is greater than 1 or equal to 1 or minimum to 1. Okay, ang minimum 1 is the non-dissociating. So there's no such value of 0. Okay? Mga palangga, which is also practical because if, for example guys, if I have a concentrated hydrochloric acid, I will discuss, okay, of course. I will connect, okay, if we have a hydrochloric acid, which is a strong acid of 100% purity, meaning purity, 100% concentrated, okay, so 100%, okay. So this is gonna be meaning equal to 1. Okay? So that's why we have mole fraction. So mole fraction, XA plus XB is equals to 1. Meaning to say, this is point something plus point something is equals to 1 because if you multiply that to 100%, it will become a chuba chuchu. 80%, 70%, 50%. It will never go beyond 100%. Okay? Now if it's not yet dissociating, of course, it's still 100 because it's not yet touched, it's not yet dissociating by itself. Okay, now if it will dissociate, of course, the concentration will decrease. 98.98%, 88%, like that. Okay, so it's also practical to say that the vanhoff factor of non-dissociating solute is 1, meaning 100%. Diba? See 1. XA plus XB is equals to 1. Meaning to say, percentage by mole. Diba? Okay, now say percentage by volume, percentage by mass, or percentage by pressure, like that, or whatever. Okay. Any questions so far mga palangga for this osmotic pressure topic, which is the last topic of colligative properties? Okay. The technique here is always consider ideal solution. Okay, dilute solution like that. Okay, and then always think that the activity coefficient alpha is equal to 1. Okay, analogous to the ideal gas, which is the compressibility factor Z is also equal to 1. Because this is ideal solutions. The word ideal, chuba-chuchu muna na siya. 111 gid siya ang mga value sa mga constants. Okay? Get the point? No, siya. Kung I will say also non-ideal solution, this will not apply already also. Okay? So it will be restricted na talaga siya. Okay? So applicable only in ideality in the solution. Okay? Once it is an ideal, of course it is a diluted. solution, meaning more of the salt rather than the solute. Okay? Ito po yung mga palangga. Any questions so far? Thank you so much for watching this live streaming on the spot vlogging as usual. And then you can comment, you can share to anybody else. And then you can subscribe my YouTube channel if you want. Okay, and then click the bell notification for some news updates of I'm a Singer, Eternal Voice. Okay, bye-bye. God bless. More problems to come, like that. So our next topic, guys, will be nagpili ko between, charot lang, between redox and what the other one is the, phase equilibria. Phase equilibria, just like a chemical equilibrium, but a little bit more of complex. There's a lot of chemical reactions to be considered, like the elementary steps, 1, 2, 3, 4, 5, like that, okay? So, it will be enjoyable if you love really chemicals. Okay? Thank you so much. Bye-bye, God bless everybody.